Now, this is called a mnemonic, yes?
Yeah.
This is called a mnemonic, and this Leo and this girl helps you remember this stuff for the test, yes? My suggestion is, when I give you the exam, you write this stuff down so you do not have to use your brain, yes? Using your brain is not the preferred method of passing this class. Okay? So, you write it down and you look here. Don't figure it out, just look here. Okay? Alright, what else? If this is undergoing an oxidation, electrons are being lost, yes? If you lose money, do you have the money? Who has the money? Somebody else, yes? So if you lose the money, or if you lose the electrons, are they going to be on the reactant side or on the product side? On the product, because you lost it, yes? Who lost it? The reactants, which is how you start. So, during an oxidation, electrons are a product here. Electrons are product. You got it? Okay, let's do GER. GER means gain electrons. Gain electrons, this is reduction. Okay? Gain electrons in reduction, what happens to the oxidation number? Oxidation number decreases. And what type of agent is this? This is oxidizing agent. It is an oxidizing agent because it is doing what? It is causing an oxidation on somebody else, yes? And this, of course, they are reactants. And reduction takes place where? In the anode or the cathode? Of course, can be the anode, yes? We already did the anode.
What are they? Anodes, cathodes.
You will see. They're called electrodes.
Okay.
Electrodes are
Like in circuitry?
the positive and the negatives, yes.
Okay.
They're pieces of metal stuck in something else. Okay, so electrons here are what? Reactants or products? Hello?
Reactants.
Electrons are reactants. Yes or no? We gotta memorize this thing, okay, for the test. Okay, let's leave the camera on then for a little bit, see how you guys behave. So, zinc has what oxidation number? 0. And this has what oxidation number? +1. And this has what oxidation number? +2. And this has what oxidation number? 0. So, zinc went from 0 to +2. What happened? Did it gain or lose electrons? It lost electrons. How many did it lose? 2. It lost 2 of them. And did those electrons go swimming? Did they go swimming? Where did they go? Did they fly? Just tell me. What do you think they did? They went straight from the surface of this metal. When that collided with this metal, they were transferred to this. Okay? They do not go swimming. You write it down. Electrons do not go swimming. They do not go flying. Okay? So, now, this here, so zinc from zinc 0 to zinc 2 plus, or from zinc +2, is what, Leo or GER? It is Leo. So if I had made a battery out of this thing, or called a galvanic cell, or voltaic cell, which one would be the anode and which one would be the cathode? The zinc to the zinc 2 plus is Leo, and Leo is what? The anode or the cathode?
The anode.
The anode. And I'm not telling you what that means yet, we're just doing robot things right now. So this will lose electrons, this would be the anode, and electrons, will they be a product or a reactant here? They will be a product. And for the other one, there will be a reactant. So this gets the electrons to become H2, and that will be GER. And would that be the anode or the cathode?
Cathode.
That is a cathode. It got the electrons that the other one lost, and then that's what happened. Okay?
So the cathodes gain electrons.
Yes.
Atoms, okay.
So, simple, yes?
Yep.
Ah, this is not that bad. Voltaic cell or galvanic cells. This is what I need you to know. A voltaic cell or a galvanic cell, it is a spontaneous cell. And this is not a cell with a nucleus, yes? And mitochondria. That's not that cell. Okay? This is another word for saying like a battery, okay?
A spontaneous cell doesn't have a nucleus?
Huh? Voltaic cell or galvanic cell are spontaneous. I mean, you can kind of read it. I think it's there somewhere. Okay? And when you place two metals with a difference in reduction potential, because of a difference in this potential energy, electrons are going to flow from one side to another side. I'm going to translate that for you. When you connect two metals with, let's say, a cable, or you put them on top of each other, if you connect them through a cable, you can use that energy that is transferred to make energy, light a bulb, yes? If you put them together, that's called a short circuit. You ever heard of that? Short?
Yeah.
They're on top of each other. What happens is electrons go from one to another. Why do they go from one to another? Because one wants to lose them and the other one wants to do what? Take them. Now the ability of this to lose or gain electrons has a name. And the name is called a reduction potential. Write it down. Reduction potential. Now reduction potential. Have you ever been told you have potential? Huh? Have you? Come on, say the truth. Have you? It's actually offensive. You should have been offended. Because if someone tells you you have potential, that means that right now you're what?
You're not doing so
You're
well.
worthless. But if someone tells you, oh, you have reached your highest potential, then that's offensive too.
You can't
You
go any
cannot
further.
improve. You're not going anywhere. If someone says you had potential, then that means you're dead
Bad.
meat. Yes?
So what's the definition of reduction potential?
The
Ability
reduction
to lose or
potential
gain
is the
electrons.
potential to be what?
Ability to lose or gain electron.
No, it's the ability to do one.
Gain
Reduction potential is the ability to be what? A reduction or an oxidation?
Okay.
Hello?
Reduction.
A reduction, that's why it's called reduction potential. So the highest reduction potential will want to be a what? A reduction or an oxidation?
We want to be an
A
oxidation.
reduction. The highest reduction potential wants to be a reduction. Okay? So the bigger that number, the more it wants to be a what? A reduction. No, not reducing it, don't change things. The highest reduction potential wants to be what type of reaction? Reduction. Whew. We're going to talk about this in a minute. I'm going to do it on the board because that's too simple for you, yes? We're going to do that one on the board later. Leo and Gurr, blah, blah, blah. Electrons flow, blah, blah, blah. I'm going to do that. Now let's do this. Volts is the unit that we are going to use to calculate something called the cell EMF. And the cell EMF stands for electromotive force. Electromotive force. It has another name, and the other name is cell potential. Now, how do you know you weigh 120, 150, 170 pounds? How do you know you weigh that?
balance tells me.
You went to Publix and you weighed yourself, didn't you? It's very good. How does Publix know?
Balance.
The balance. Sure. How does the balance know? Because the balance is stupid. From what I can see, the balance is a piece of metal. How does the balance know? It is compared to a standard. That's right. Without a standard, I cannot do any calculation. Somebody has to agree 1 gram is 1 gram, or 1 kilogram is 1 kilogram, and everybody has to compare whatever they have to that standard, yes? Now, in order for us to do calculations with this, we also need a standard. And the standard for reduction potential is called She. She, S-H-E. Of course, girls are the source of all trouble, including this one.
For reduction potential?
Yes.
I thought we were talking about slope potential.
So She, you see it there? It's called standard hydrogen electrode. Yes? And that is the standard that is used to calculate or to determine reduction potentials. Once you determine the reduction potential as a comparison of this with everything else, you get a table. And this table is called electrochemical data. Blah, blah, blah. There is a famous table. In this famous table, the standard hydrogen electrode is the reduction of H plus gain electrons. Is this a reduction or an oxidation? Electrons are what? Reactants. Come here. Electrons are reactants. What's that called? That is called a reduction, yes? So all of these reactions here are what type of reactions? They are reductions. That's why on the top they're called reduction potential. Yes or no? The standard for that is called the standard hydrogen electrode. And the standard hydrogen electrode is this reaction you see here, and it gets a reduction potential of 0. Everything is compared to that. Okay? Now, this means what? This is the highest what? The highest, not potential. The highest reduction potential, not just potential. This is the highest reduction potential. What this means is that this wants to do what? It wants to gain an electron. This means that whenever you put this somewhere, what is this F2 going to do? It is going to take an electron from whoever has one. So, if you were to make fluorine gas and you were to breathe this, what would happen? Yeah, you die. Okay, if you were in the presence of this, it'll take all the electrons from your body. Okay, until there's no more electrons left, and you are probably gonna be, I don't know, maybe a blob of stuff on the floor.
Oh my God.
So, it's a pretty good death for a Saw movie, yes? You know, how the face starts melting and the eyeballs come out. All right, so I had a dream last night with this stuff. So this is the highest reduction potential. So if I were to mix this with something here that is beneath it, the one on the top is going to be the reduction. And the one underneath cannot be another reduction. The one underneath has to be an oxidation. Yes, I said A, kind of confused. So the number on the top will be a reduction, and the number below that will be the oxidation. But the oxidation, is it going to look like this? No, the oxidation will actually be the reverse of this equation you see here. Okay, I'm going to tell you how to build one of these things in a minute. Guys, is that clear? Yes or no? Hello? What's this? What is that you are in the presence of? What's that called? This is called a reduction potential table. And what does it give you? The reduction potential of everything. Is there such a thing as an oxidation potential table? No, there's no oxidation potential table. There's only reduction potential table. And everything here is a reduction. And all of these numbers were obtained from having what standard? Standard hydrogen electrode, better known as She. Of course, and you remember, girls are the source of all trouble. Yes?
So professor, so the highest potential is the one with the higher number. I mean, the one who's gonna reduce the most. The first one.
Yes. Okay? Yes or no? So let's build a galvanic cell, which will be a spontaneous cell, and we're gonna build one from copper and zinc. Okay? You have access to copper in your house, and you have access to zinc as well. Yeah, so you can make this in your house. So here's copper. write down the reduction potential of copper is plus 0.34. And the other one will be zinc. The reduction potential of zinc is minus 0.76. The units for this are joules. It's volts, yes? And volts are joules per C on the bottom. And this C is what? For the physics guys. Joules per unit of charge. What? Who? You gotta speak up, they can't hear you. You're shy. I'm shy too, I can't pronounce it well, so I always say the wrong word if you speak Spanish.
Yes.
You know, so I have problems saying that. It's joules per, somebody say it.
Coulombs.
Coulombs?
Coulombs.
Okay, all right.
Some coulombs. Well.
Okay. There it is, 1 volt, joules per. Very good. Oh, I get it. Okay, let's do. Let's build one of these things, yes? We are going to build right now a galvanic cell, yes? Or a voltaic cell. So what we are going to have is, we are going to have 2 containers. And try to draw it like this, okay? We're going to have 2 containers. I am going to put an electrode inside of one container. And this electrode could be the anode or it could be the cathode. Just a piece of metal. And it will be swimming in some type of liquid. So this metal is zinc. Okay? The ions that I'm going to have inside of this compartment are going to be zinc ions. I am going to connect this electrode to another electrode on the other side. Do the electrode on that side of the tube, okay, on that side of the compartment. And this one is going to be made of
Copper.
copper. Let's write it on the same place I wrote it here. It's be made of copper. And what type of ions am I going to have swimming in here? Copper ions. Very good. Of course, you cannot have a positive without a negative, so more than likely, this will have a counter ion somewhere here. Most of the time, it's not Cl minus, because Cl minus will precipitate with lead, silver, mercury, stuff like that. In general, is the conjugate base of a strong acid. Let's put nitrate, okay? Sometimes sulfate. So, let's put nitrate here. It doesn't matter if it is really nitrate or not. What I want you to know is that if you have a positive, you must have something that is negative, and they're swimming in there, everybody together. Now you are going to connect these 2 things with something called a salt bridge. And you'll never guess what's inside of this salt bridge. Salt. Very good. Salt bridge, and inside of this salt, you'll probably have something like sodium or potassium, and something that is negative, of course, like maybe nitrate, something negative, okay? So, and the purpose of a salt bridge is to close the circuit. Without the salt bridge, there is no electricity that flows anywhere, because the circuit is not closed. Yes or no? I connected this thing here to that with a what?
Salt bridge.
No. The compartment was connected with a salt bridge. I connected this electrode to that electrode with what? With a copper wire. Yes? I connected it with a copper wire. I interrupted this copper wire and I put a voltmeter in it. And guess what the voltmeter measures?
Volts.
The voltage of this cell, yes? The EMF of the cell, or something called cell potential. Yes or no? What does it measure?
Voltage.
Voltage is not the name of it. What does it measure, guys? The EMF of the cell or cell potential. And this voltmeter will have like a little thing that is going to measure the voltage of this thing, or it's going to measure the EMF of the cell, or it's going to measure the cell potential. One of them is going to be the oxidation, the other one is going to be the reduction. Which one has the highest reduction potential? Hello?
Copper.
Copper? What's the reduction potential on copper?
Loss 0.34.
0.34 volts, okay? Positive 0.34 volts. Yeah.
The voltmeter shows what?
EMF of the cell or cell potential. So copper is 0.34, so that means that copper versus zinc, and I am not putting ions on this or anything. What is zinc?
Negative 0.76.
Okay, very good. So that has a higher reduction potential. This is going to be the what? The reduction. Okay, so which one of those two is going to be GER?
Copper.
Copper is going to be GER. And I am doing this because I want a short way of saying what I'm going to say next. And zinc is going to be what? Leo. So, what is zinc going to do? Oh, which one is the anode and which one is the cathode? Leo is the anode, yes. And GER is the cathode. So, this is called anode and this is called cathode. And what happens at the anode? Electrons are lost. Yes? Electrons do not go swimming. Yes? They go along this wire. Electrons are lost here. Yes or no?
Okay.
Electrons are lost here at the anode and they move towards the cathode. So electron flow is from, hello? Electron flow is from
Anode to cathode.
anode to cathode. Okay, I guess that goes in alphabetical order, yes? Electron flow from anode to cathode. What type of agent would that be? What type of agent would this be? This would be a reducing agent, and that would be what? Oxidizing agent. Okay, very nice. If this is losing a lot of electrons, what charge should it be? It's confusing. One of them has to be positive and the other one has to be negative, yes? This one has a lot of electrons to give, so it must be
Negative.
negative. Because if it didn't have a lot of electrons to give, it would not want to give, yes? And electrons are negative. So this will be negative and this will be positive. This is not the same thing in physics. Current is the movement of positive charges, and here we're talking about negative charges. So these signs will be reversed
Okay.
in physics because they're talking about in a cable. The electrons move that way, the current is this way. Okay? Don't worry about it. Okay? Deal with that when you take physics. What else? Now we can calculate something called EMF of the cell, or better known as cell potential. Yes? And that's called cell potential or EMF. It's the same thing, okay? And the equation for that is, the mnemonic that I prefer you use is CAT. Who likes cats? That's disgusting. Cats are traitors, yes? When you die, they will drink your blood. When you die, a dog will stand next to you until he dies of hunger. That's what I'm talking about, loyalty.
Yeah.
I'm a cat. It's a cat. You eat cats.
They'll be like, now they feed me human, you're dead.
Emily, you like to eat cats? No? I had a person in Cuba that ate my cat. He ate my cat. I love cats until that day. He ate it. All right. Cathode minus anode. This cathode is the reduction potential of the cathode, okay? Reduction potential. So let's say E of the cell, and I am going to use the reduction potential. And this reduction potential will look like E reduction, okay, that's the reduction potential, minus the reduction potential of the other ones, because they're both reductions. The only difference is that this is the reduction potential of, I was going to write it down, reduction potential of the cathode minus the reduction potential of the anode. If that gives you a positive sign, as you see here, the letter T, yes? If it gives you a positive sign, that will be spontaneous. If it gives you a negative sign, it will be non-spontaneous.
Is there any reason you didn't put one of those small little circles over the reception of the anode? The standard condition circle?
Yeah, of course, there is a reason, and the reason is I am not thinking, yes? Okay, so what we are going to do in order to calculate the EMF of this cell is the reduction potential of the what? Of the cathode. Which one is the cathode?
Copper.
Is this the cathode or is this the cathode?
No, copper.
Cathode is copper, 0.34 volts, minus the reduction potential of the anode. And what is the reduction potential of the anode? Minus 0.76 volts. That will give you 1.10 volts. That's the EMF of this cell, or called cell potential. So the voltmeter should read what number? 1.10 volts. Okay? Your car battery has a what voltage? How about your cell phone battery? How about a AAA battery? AA? You don't know anything. Have you ever looked at them, read them? No? Yeah, who cares? I just put them in. All right, very good. Now, as this is losing electrons, what happens to this zinc piece of metal here? As it loses electrons, what does it become?
It gets oxidized.
What does it become as it loses electrons? It becomes zinc 2+, yes?
Oh, okay.
So this metal here, on this surface, is losing electrons. And what is it doing to the concentration of zinc 2+? It is making it go up. So the concentration of zinc 2+ is going up on that side. And what is happening to this surface? Is it getting fat or is it getting thinner? Because it's being lost, it's going from zinc metal to zinc 2+. What's happening? This is getting thinner, right? It's going like this. So we are going to say that this is losing mass. How do you remember this? Well, lose electrons what? Lose mass. So the concentration of zinc 2+ is increasing. Now you have here a concentration of a positive charge going up. If a positive charge goes up here, something has to cancel that out, yes? So what needs to happen is, let's say that something is going to go in here to cancel that. What is it going to be, a positive charge or a negative charge? Negative charge. So in here, there is going to be the flow of NO3- into this compartment. Now, of course, the zinc could also go inside of that, but let's say that NO3- is coming in, coming through that hole to this side to neutralize that. Now, what's happening here? What is happening here is that this copper, once it has the electrons here, is going to gain the electrons, and it's going to go from copper what to what? It's going to go from, no, It's going to go from copper 2 plus to copper. This is GER, yes? Gain electrons plus 2 electrons will give you what? Copper solid, yes? This is called a reduction. The oxidation was zinc solid will make zinc 2 plus, which is what that did, right? Lost the electrons and became zinc 2 plus 2 electrons. These 2 electrons were the ones used for this reduction, yes? So, the copper here is going to be what? Go from copper 2 plus, because it's going to gain electrons, going to go from copper 2 plus to copper solid. So what's going to happen to the surface of this? Is it going to get fatter or thinner? It's going to get fatter.
Gaining
So,
electrons. Yeah.
it is gaining electrons, gain mass. So that one gets fat, while the other one gets thinner. Fact of life. What happens to the concentration of copper 2 plus as it's getting attached and becoming copper solid on top of this?
Going down.
Concentration is going down, and if the concentration of a positive ion is going down, something has to flow through this. Let's say that what is going to flow is positive. Now, of course, things can flow in and out, right? So let's say that this is what happens. Na plus then flows through that. And this flow of electrons, and that flow of electrons, this flow of charges closes the circuit, okay? And then if you put a light bulb here, it will light it up, or it will have that type of voltage or energy that you can use to power things. Yes or no? Let's do the equation for this. The equation for that cell will be copper 2 plus, we did it here, copper 2 plus, the 2 electrons cancel with the 2 electrons, yes or no? So copper 2 plus zinc solid, this is aqueous, will give you what? Will give you copper solid plus zinc 2 plus. You agree? Yes or no?
Yes. Wait, where are you getting? Oh, no.
So if you guys wanted to do this the fast way, okay, and I told you that this is a galvanic cell voltaic cell, and you wanted to calculate the EMF of this, you don't have to write anything down. Just get the big number, subtract the smaller number. Yes? Number on the top minus number on the bottom will give you a spontaneous cell.
And you're gonna
Yes?
give us those values, like a mini chart with those.
Yeah, I'm gonna give you the chart with the values in it.
Okay.
Yes or no, guys?
Yep.
And this is not on next class's test, right? It's only in the final.
Yeah, this is only in the final. Entropy was only in the final. Okay?
Oh,
If I need to teach things on Tuesday, we're gonna show up on Tuesday of next week and I'm gonna teach you more stuff. Okay? Yes? Okay, so let's talk about this for a minute. Let's finish this and I'm gonna do 1 or 2 problems and that's it for now. So here is the reduction potential table, yes? The numbers on this side, or these up here, they want to be what, a reduction or an oxidation? They want to be a reduction, yes? So, they want to be a reduction. These numbers up here want to be a reduction. They have the highest reduction potential. So what type of agent are they? They are, since they want to be a GER, they are what type of agents? Oxidizing agent, because it's the reverse of GER, yes? Now, as you start going down, they want to be less and less reduction. So these down here, what do they like to be? As compared to the ones on the top, they want to be an oxidation. But the oxidation is the reverse of this. So these elements on this side of this table want to be what? Oxidations. So what type of agents would they be? Reducing agents. You have to remember, I give you this table like this. Reduction potential table. These here want to be what type of agents? This is GER, yes? GER. This is oxidizing agent. Oxidizing agent. The most oxidizing agents are these on this side. And totally opposite to that, on this side are what type of agents? Reducing agents. They are products here. So I may ask you on the test, which one is a stronger reducing agent? F2 minus or H plus? I mean, F2 or H plus, which one is a stronger reducing agent? Okay, trick question, okay? Compare, let's say, let's compare copper and zinc. Copper and zinc. Here, copper and zinc. Tell me, which one is a stronger oxidizing agent? Copper what? Not copper. Copper what? Copper 2 plus. Stronger oxidizing agent is on this side. But which one is the strongest reducing agent?
The opposite.
It's not this on this side, yes? Not that. Reducing agent is that. Zinc solid. Okay? So on one side will be oxidizing agent, on the other side would be reducing agent. Yes or no? From these two, iron and zinc, which of these two is a stronger reducing agent?
Alright. I mean, zinc.
The one below is the strongest reducing agent. So on this side, I can compare these and say zinc is a stronger reducing agent. What that means is if you put iron and you put zinc on it, which one is going to get reduced first and is going to get messed up first? Zinc is going to get messed up. This is why you have on the boats, you have the zinc that is attached to the engine of the boat. So instead of the iron getting messed up, what gets messed up is the zinc. You ever seen that before?
Yes.
You never seen boats? It's good. You never seen boats? Okay, turn this thing off.